Today is January 13th, and this is the hard daily integral for today. Please take a minute to pause and try it out for yourself. And now we'll start. So here are a few formulas which will come in use. This is the Taylor series for sine of x. This is the general Laplace transform, and this is the Laplace transform for t to the nth. This is for a general function. So please try it out for yourself and using these formulas, and now let's see how we can do this. So first off, we see a sine of x over x. This is clearly not something elementary. We cannot easily integrate this. That's why we're going to substitute in its Taylor series. So we'll have, first take out the 67, we'll have e to the negative x over tangents of 1 sine of x over x. We can use this summation to get n equals 0 to infinity of x to the 2n. One of the x's is divided, so we have x to the 2n plus 1 factorial times negative 1 to the nth dx. Now what we'll do is we'll interchange the order of summation and integration. And then we can take out the negative 1 to the nth and 2n plus 1 factorial since they're independents of x. And now we'll have the integral from 0 to infinity of e to the negative x over tangents of 1 x to the 2n dx. So this right here is very similar to what we have right here. So this means we can use the Laplace transform to be able to find out what the value of this integral is. So let's see how we can do that. So first off, let's write out the Laplace transform of t to the 2n. So this is equal, since we have a 2n here, it makes sense for us to take the Laplace transform of t to the 2n rather than t to the n. So we have the integral from 0 to infinity, e to the negative st, our f of t is t to the 2n dt. And we know that this is the same as 2n factorial over s to the 2n plus 1 from this formula right here. So now we know that our s, so we can call this a function f of s. So we know that s in our case is 1 over tangents of 1. So we can now write 2n factorial. So we can write f of 1 over tangents of 1 is equal to 2n factorial over 1 over tangents of 1 to the 2n plus 1. This is the same as 2n factorial tangents of 1 to the 2n plus 1. And this is the integral from 0 to infinity of e negative t over tangents of 1 t to the 2n dt. The only difference here is we use t and in here we used x. So we know now that this integral right here is equal to this value right here. So let's plug that in now. You'll have 67, the sum from n equals 0 to infinity, negative 1 to the nth, over 2n plus 1 factorial times 2n factorial times tangents of 1 to 2n plus 1. So what is this now equal to? Well, we can see that we have a 2n factorial over a 2n plus 1 factorial. So that'll become 1 over 2n plus 1. We have a negative 1 to the nth still. And we have a tangents of 1 to 2n plus 1. So here we have another Taylor series, which should feel familiar. This is the Taylor series of arctan of x. So let's write this out. Arctan of x is equal to the sum from n equals 0 to infinity of 1 over 2n plus 1, negative 1 to the nth, over 2n plus 1 of not tangents, that is the value we plugged in, if x to the nth. Here we just plugged in x equals tangents of 1. So now we can use this and write arctan of 1, arctan of tangents of 1. So we just plug in our value of x. So this gives us 67.